All right, let's go over the study guide review problems. Okay, number one, the temperature of a 74.4 piece of copper increases from 25 degrees to 48 degrees Celsius when the copper absorbs 849 joules of heat. What is the specific heat, C, of copper? All right, so we know temperature, delta T, is equal to temperature final minus temperature initial, which is temperature initial 25, temperature final 48. So 48 minus 25 equals 23 degrees Celsius. Now we have mass, we have Q, we don't know C. All we got to do is plug it into Q equals MC delta T, 74.4 mass, and then C is question mark, and then delta T, which we figured out was 23, equals 849 joules. 849 joules. The way you solve it is you get 849 divided by 74.4 times 23. So that gives you C. So when you calculate that, your C value is going to be 0.496, which I'm going to round to 0.5. So 0.5. Units for C are always joules over grams times degrees Celsius, unless it gives you other the data in other units. All right. The universe is made up of systems and surroundings. Systems is what you study, and surroundings, everything else. Horrible handwriting, but you have to make watch anyways. Heat is transferred from the system to the surroundings in the system. Think of a ball. Think of a ball, big ball here. And if heat is transferred from the system, the ball, to the surroundings, so heat goes out, heat goes out, horrible squiggly lines, but heat goes out. The system, the heat exits exothermic. Exothermic. Exit exothermic. All right, think of a ball now again. When heat is transferred from the surroundings, so the environment inside the ball, the heat enters, so it's endothermic. Endothermic. Endo, enter. All right. Third question. A peanut is burned under a pop can calorimeter, and it causes 100 milliliters of water to increase from 21 degrees to 28 degrees. How many calories or heat? Or we're going to change that. We're going to joules. How many joules of heat were released by the peanut? How many calories? All right. So you're given with 100 milliliters, and we know water is special because of its density. That means milliliters of H2O equals grams H2O, and same for liters equals kilograms. So this essentially is 100 grams. So now we have mass, m, grams, and we need to calculate delta T. Delta T is going to be, horrible. Delta T is temperature final, 28, minus temperature initial, 21. That gives you 7 degrees Celsius as delta T. And we're looking for the Q value of heat. Q equals question mark. And we know that the water's specific heat capacity value is 4.18 at the liquid state, the liquid water state. 4.18, and if you want units on that, it's going to be joules per gram. No. Yeah. Okay, just ignore the unit for now. Q equals mc delta T. M, mass of water, we calculated using the special rule 100 times value of C, 4.18. And then we have delta T, which we calculated was 7. And all we're going to do now is multiply 100 by 4 times 18 times 7. And we are going to get, we're going to get 2,926 joules, 2926 joules. All right, so now we know that the amount of energy created was, or not created, you can't create energy. Energy generated was this much in joules. Now we got to calculate in calories. So the conversion factor is for every 4.184 joules is 1 calorie. This will be given on your test. So all we got to do is, this is one answer. All we got to do is 2926 joules 1, convert it using dimensional analysis, 4.184 at the bottom, and the 1 calorie on top. And then that should give you around 699, which I'm going to say 700 calories. So there are 700 calories. All right, so number 4. What is the energy absorbed when 25 grams of H2O mass is heated from 75? This is temperature initial, this is temperature final. So we can calculate delta T. Draw a diagram and show all your work to earn credit. This following comes, yeah. It gives you all those numbers. All right. So what is the energy absorbed? You're gaining energy when 25 grams of H2O is heated from 75 degrees Celsius to 115. So we want to draw these handy graphs. Um, the one that looks like, hold on, that's a little, one that looks like, oh, one that looks like this. All right, so that's 100, and that's 0 right there. And we're going from 75 degrees to 115 degrees. So let's say this is 75, and since this is 100, we're going to go a little above 100, 115 based on the directions. So you're going up 1 here. You're switching phases here. And we're going up a little more to go to 115. So we have 3 Qs we need to solve for. Wow, that's a lot. Q1 here, Q2 here, and this is going to be Q3 right there. Q3. All right, so now we need to know the delta T. So the delta T is calculated using temperature final minus temperature initial. So you can't just grab these values and calculate. You got to look on the graph. So this is 100. This is 100 because the 100 goes like this. So we're going from 75 initial final 100. So it's going to be 25 degree or delta T equals 25 degrees Celsius. And then there's no temperature change on this line right here because it's only changing from a liquid to a gas. And this part right here, delta T equals temperature initial is 100, you're ending with 115, so it's going to be 15 degrees Celsius. All right, so now we have all our data that we need. So all we got to do now is calculate. So let's start with Q1, which is this here. We're going to use Q equals mc delta T because we know there's a temperature change. Mass of water is 25. We have it circled right there. And then C for water at liquid. This is liquid. This whole section right here that I'm going to highlight right here. This is liquid. So that means we got to use the C value for liquid, which is CP water right here, 418. 4.18 times delta T, which we figured out this delta T corresponds with 25 degrees Celsius. And we multiply all 3 of those together to get your Q value, which is going to be 2,612.5 joules. All right. Now let's calculate Q2. This was Q1, so we're going to calculate Q2. This is M times delta H because there's no temperature change. And since this is going from a liquid to a gas, we're going to use the M times delta H for vaporization, VAP, which is we're going to use dimensional analysis to solve. So we start with 25 grams of water. We have 18.02 grams per mole of water. And then each mole, 1 mole, this is the important part. So on our givens, we know that the H vape is 40.7 kilojoules per mole. So that's going to be kilojoules and then moles right there. And then 1 kilojoule is 1,000. The prefix kilo means 1,000, 1,000 joules. And all we got to do now is solve for that. So we multiply 25 times 1 times 40.7 times 1,000, and divide it all by 18.02. That should give you 56,465.04. We're just going to say that joules. Okay. Now we got to calculate the third and last Q3 value. So we have Q3 equals, this one has a temperature change, so we're going to use MC delta T. MC delta T. Mass of water is 25. C, this time we got to look at the C value, it's different. So this is now at a gas, so we only use the C for gas right here. Where is that? Steam, right here. We're going to use 1.9. And then we're going to use delta T, which we figured out earlier was 15 degrees Celsius. Same thing as number 1, or Q1. Multiply it all together. 25 times 1.9 times 15. You're going to end up with 712.5 joules. Joules. All right, so now this is simple. So we just got to add all these together. So the heat total equals Q1 plus Q2 plus Q3, which is going to be these three values, this one, and this one added together. So when you add all these together, you end up with 59,790 joules. And that is your answer. All right. Let's do the last question together. Okay. So, all right. So what is the energy released? So you're looking for Q. When 37 grams of water, M, is at 25 degrees Celsius, T initial, and is cooled to negative 30, T final. Okay, so now we're just going to calculate delta T since we're given temperature, equals temperature final minus temperature initial, 25. It's going to be negative 55 degrees Celsius. All right. Actually, just kidding. Don't do that. Don't do what I just did. Foolish mistake. All right, we're going to draw a graph first. Same thing we did for number 3. Um, we're going to draw, that's kind of big. Hold up. Let's draw it like this. All right, we're going to have a graph. And then we're going to get these lines. And this is 0, as always. This is 100. 100. All right, and we're going to look to see how this travels along the line here. So you're starting at 25 degrees Celsius, which is, let's say, around here, 25 degrees Celsius. And you're moving down, you're hitting here, this point right here, converting from a liquid to solid this way, and you're hitting eventually at a temperature of, let's say, negative, right here, negative, this says negative 30, negative 30 degrees, which is right there. So we're going to look for a total of 3 Qs. 1 Q here, 1 Q there, and let's see, Q2 here, and then Q3 here. All right, wonderful. So don't do what I just did and, find that on your own. Um, draw a graph first. So let's start at Q1. Q1, we're looking at a temperature change, MCAT, MC delta T, M37, M, C. C for water at liquid is 4.18. And then T, temperature is, we're going to find the delta T for here. So we're starting at 25 and we're ending at 0. So the temperature initial is 0 minus 25. Therefore, temperature delta T is 0 minus 25, which is negative 25 degrees Celsius. All right, we're just going to calculate this bottom part. Might as well just do it now. Delta T equals, you're starting at 0 and you end at negative 30. So negative 30 minus 0 equals negative 30 degrees Celsius. All right, beautiful. Okay, so now we have the Q1 value, temperature, which is negative 25 degrees. And that, you multiply all of that together, and it gives you negative 3,000, negative 3,866.5 joules. All right, Q2 now. Q2 is, there's no temperature change from Q2, which is this here. So we're going to use M times delta H. And since we're going from a solid to a liquid, or liquid to a solid, we're going to use fusion. Delta H fusion. Delta H FUS. Right there. All right. We're given 37 grams. We're going to solve using dimensional analysis. Okay. And then we have 18.02 grams per 1 mole. And then 1 mole, and then this is where the information comes. So this right here, the delta H fusion, the value for that is going to be 6.01 kilojoules per mole. And this is given on your test. You just got to scroll up, and then you want to calculate how many joules are in a kilojoule, 1,000 joules. All right, and all you got to do is multiply across the top and divide it by everything on the bottom. And when you divide 37, or you multiply 37 times 6.01 times 1,000, and then divide that by 18.02, you're going to get negative, because it's energy released. This is the important part. Since we had a negative here, we know that it's energy released. So then we're going to have a negative. You always got to put that yourself on the dimension analysis parts. Negative 12,340. 0.2, but we're just going to put that. Okay, joules. All right, the third part, Q3, we have a temperature change. We're going down. So we're going to use MC delta T, 37M. C, this time it's a C for gas value. So the C for gas value is going to be 2.1. And then times the temperature delta T we found was negative 30. Multiply all that across, and you're going to get negative value, negative 2,331 joules. Negative, negative, because it's heat released, energy released. All right, so now all we got to do to find Q total is Q1 plus Q2 plus Q3, which is negative 3,866.5 plus negative 12,340 and plus negative 2,331. And you should end up with a total value of negative 18,537.7. If you put a negative 0.2 there, so you're going to put a 0.5 here since we add all this together, joules. So this is the amount of energy and heat released when the water is cooled.